You can find the area of a triangle using 1/2 the base times the height, or you could also do area equals 1/2 BC sine of A, where B and C are the side lengths that make up the angle measure. So I'm going to do area equals 1/2 2 times 3 times sine of 35 degrees. So make sure when you put this in a calculator, round to the nearest hundredth, which is 2 decimal places, and make sure that you're in degree mode. So this triangle has an area approximately equal to, because I rounded, 1.72 centimeters squared. I'm going to do the same thing over here. So it's going to be 1/2 BC sine of A, so it's 1/2 14 times 11 times a sine of 65. I put it in my calculator, I make sure I'm in degree mode. 1/2 times 14 times 11 times sine of 65. Rounded to nearest hundredth, which is 2 decimals, is 69.79 inches squared. Okay, then find all lengths and side lengths and angles in the triangle below. Use law of sines and cosines. So if I'm looking at this one, I always try to do law of sines first, but I have an angle and no side opposite, and I don't have any other angles. So because it's a side angle side situation, I need to do law of cosines to figure out what this is. So this is lowercase c, so c squared equals 21 squared, that's A, plus 27 squared, that's B, minus 2 times 21 times 27 times the cosine of 33 degrees. So I use law of cosine formula. So I'm going to put this all in my calculator, and I can do it all at one time because I'm going to take the square root. So in my calculator, I'm going to do square root and then parentheses, keep this all underneath the square root. And I'm going to round it. So this C is approximately equal to, it's approximately equal to 14.8 if I round the nearest tenth yards. And now I need to find other angles. So I'm going to hold this number in my calculator and use salt law of sines. So I'm going to do sine of 33 is to this number right here. I'm going to keep it in my calculator as the sine of B, because I'm going to find angle B, is to 27. So to solve for B, sine of B, I'm going to multiply this expression by 27 in my calculator and then do the inverse of it. And I get about, the angle B is 83.6 degrees. So when I do this, I try to hold things in my calculator so I'm not rounding and rounding. So if angle B is 83.6 degrees, then I should be able to do 180 degrees minus 83.6 minus 33 is going to give me the last missing angle measure, which is 63.4 degrees approximately. And then down here, find the measure of angle A. So because I have all sides, I have to use law of cosines. So this is going to be my angle here. This is the side opposite. So this needs to be 25.6 squared equals A squared plus B squared. The letters don't really matter, but the two sides that make up the angle are 17.7 squared plus 28.7 squared minus 2 times 17.7 times 28.7 cosine of angle B, or angle A. So what I'm going to do is, a common mistake is people put this number here with these two terms. So what I need to do first is I need to subtract these two from each side. So I put 25.6 squared minus 17.7 squared, and then also for subtract I also need to subtract 28.7 squared. So when I do that, I get, if I subtract this quantity from each side, I get negative 481.62 equals, and then I'm going to multiply this right here. So I'm going to multiply negative 2 times 17.7 times 28.7, and I get negative 1015.98 cosine A. So the next part, I'm going to divide both sides by this expression, and then I'm going to do cosine inverse to get the angle. So I get about 61.7 degrees if I round to the nearest tenth. And then the last one on here, solve for h in the figure. Round your answer to the nearest hundredth, so 2 decimals. So h is made up with this right triangle. So I can't do the Pythagorean theorem. What I could do is figure out what this side is by using law of sines. And I could figure out this angle because this has to be 75 degrees. Because these two are supplementary. So I'm going to pause it and do law of sines to figure out what this segment is. So this segment ended up being to the nearest, this was 9.875, etc. in my calculator. And so now you have this triangle right here, this right triangle, and you have the hypotenuse. This is the hypotenuse because it's opposite the right angle. And you also have, and you want to know the opposite. The opposite of 75 is the h. So I'm going to use the sine of 75 degrees equals opposite over the number I held in my calculator. So I'm going to multiply the number I held in my calculator, 9.875, etc., times the sine of 75 to get what h is. So h is approximately equal to 9.54 to nearest hundredth. I'm going to find the exact values a different way. So this works for if you have something that is not 30, 60, 90, multiples of those, but in fact sine of 240 you can actually just do straight up, but I'm going to show you I can use the angle or sum difference identities. So I'm going to think of two angles that are close to 240 that I can either add or subtract to get 240. So I'm going to use sine of 240 is the sine of 180 plus 60. So this is going to be my A and this is going to be my B. So there's different ways to do it, but this is the way I'm choosing right now. So I'm using this formula right here and doing sine of 180 times the cosine of 60 plus the cosine of 180 times the sine of 60. So if I evaluate sine of 180, that's the y value at 180 degrees, that's 0. So this part's going to be 0. And the cosine of 180 is negative 1. And the sine of 60 is root 3 over 2. So in the end, I get negative root 3 over 2. So for the second one, the tangent of negative 300, look back at my tangent of negative 300 I could just do, but I'm going to use this formula here. And I'm going to do the tangent of 300 is the tangent of 60 minus 360. So I'm going to write that as tangent, this is my A, this is my B. So it's going to be tangent of 60 minus tangent of 360 over 1 plus tangent of 60 times tangent of 360. Okay, so I started evaluating this, and this would be tangent of 60 is root 3, tangent 360 is 0, 1 plus tangent of 360, but this part's going to be 0. So if this is just going to be root 3. So the answer is root 3. Okay, and then to get 105, I'm going to do the sine of 45 plus 60. Because that's 105, but it's actually the opposite of that. So remember our negative angle identities, that if you have sine of negative theta, that's actually equal to the opposite of sine of theta. So this is actually going to be the opposite of sine 105. So we're going to do the sine of 105 using this formula over here. I'm going to substitute it in. Okay, kind of messy, but the sine of 45 is root 2 over 2. The cosine of 60 is 1/2. Plus, the cosine of 45 is root 2 over 2. Times, this is 60. The sine of 60 is root 3 over 2. So this first part's going to turn into root 2 over 2. Plus, the second part's going to turn into not root 2 over 2, but root 2 over 4. And the second part is root 6 over 4. So you can't combine these together, but just write root 2 plus root 6 all over 4. And remember, it was opposite because of what we did initially in the beginning. In these next two, cosine of 50, cosine of 4, what is this coming from? So what you're trying to do is look at your original angle sum identities or angle difference identities and see which formula matches up with this. So to me, this looks like, or this is this one right here. This is cosine A, cosine B, cosine A, cosine B, sine A, sine B. So this is actually the cosine of 90. Now you need to evaluate the cosine of 90. What is the x value at 90? And the answer is 0. So number 5, I'm going to look at what formula does that look like. Well, it looks like the sine of A plus B. So this is actually the sine of 270. So what's the y value at the sine of 270? So 270 is down here. So the y value is -1 is the answer. So to evaluate those, you want to look at what does it match up with.